Welcome to this tutorial on using the H2 Blue hydrogen test reagent to measure dissolved hydrogen levels in your hydrogen water. I'm going to be doing this presentation in two parts. The first part will be a short PowerPoint presentation giving you some fundamental principles and concepts behind the H2 Blue test reagent. And then in part two, I will actually do a video showing how to use the reagent to test for your dissolved hydrogen levels. Let's take a look at an overview of the procedure we'll be using to measure our hydrogen water today. The hydrogen water source we're using today are the hydrogen tablets. These tablets contain elemental magnesium, and when they are placed into water, they react to produce dissolved hydrogen gas. We want to use a 500 milliliter glass bottle with a good seal so that we can contain the pressure, and that will ensure that we get a good high level of dissolved hydrogen gas. We're going to allow that tablet to dissolve for between 20 to 30 minutes. And you can do less if you want. You could do a lot more if you want, because the tablets will continue to react over a number of hours. And the longer you let them dissolve, the higher the levels will be. Our sample size for the measurement is going to be a 6 milliliter beaker. We're going to pour off 6 milliliters from the bottle, and we're going to measure that sample using our H2 Blue reagent, counting the drops as we go. And keep in mind that although we're using magnesium tablets in this particular measurement, you can use hydrogen water from any source, whether it be an alkaline water ionizer. You could use the new HIM machines, the hydrogen infusion machines. You can use H2 Blue on magnesium sticks, even water bubbled with hydrogen gas. H2 Blue works just fine for all of these. When we measure the dissolved hydrogen gas levels in water, we're doing what's called a titration. A titration is a method of determining the unknown concentration level of a substance, in our case H2, dissolved in a solution of known quantity, 6 milliliters of water, by adding a reagent of known concentration, the H2 Blue, in carefully measured amounts, drops from the bottle, until a reaction has completed, called the titration endpoint, usually indicated by some change, in this case a color change. The water stays blue in the sample. To put the titration into simpler terms, we're going to start adding drops of H2 Blue to our sample of H2 water, and the first few drops should turn clear. We're going to continue to add drops until they no longer turn clear and instead remain blue. That's how we know we've reached the end of the titration. Let's look at the chemistry behind H2 Blue. H2 Blue contains a molecule called methylene blue, and if you put methylene blue in regular water with no hydrogen, it will stay blue. That's because on the methylene blue molecule are two binding sites which, when properly catalyzed and mixed with hydrogen gas, will bind a hydrogen atom to each of these binding sites. And in doing so, this actually changes the way the molecule reacts with light, so that now the blue will turn clear in the presence of hydrogen gas. And this will continue to happen until we put in enough drops so that we run out of hydrogen, we consume all the hydrogen, and now the next drop we put in will remain blue. Let's look at the procedure we'll use to prepare the hydrogen water using a magnesium tablet. We're going to use glass bottle in this case. You could use plastic if you would like, but it must be able to withstand a good amount of pressure. It must have that good seal we talked about, capable of holding the pressure, because the pressure helps the H2 to dissolve into the water. Typical volumes range from 500 milliliters, or 16 ounces, up to 1 liter, or 32 ounces. Just keep in mind that the smaller the container that you use, the higher the reading you're going to get, and the larger the container, you'll get a lower reading. That's because we produce with one tablet a finite amount of hydrogen. So if you place that finite amount of hydrogen in a larger volume, obviously the density will be lower and you'll get a lower reading. Using the tablets, one tablet is sufficient for therapeutic levels of H2. You want to be careful using multiple tablets because you could fracture the container if the pressure gets too high. We like to fill this container all the way to the top with no air gap because any gap of air will reduce the total amount of pressure produced by the hydrogen gas that's being produced. You want to place a tablet into the container and then immediately close it up and allow it to start reacting. As I said before, tablets can be left in the water between 5 minutes up to 8 hours. We're going to use 30 minutes. Longer times produce higher concentrations. Let's take a look at the measurement procedure for measuring the dissolved hydrogen level using the H2 blue reagent. The first thing we're going to do is open our H2 water container. If we've used the magnesium tablets to generate our hydrogen water, then they will be under pressure, and when you pop that top, you'll hear a little popping noise as the pressure is released. We want to fill the beaker, which is provided with the kit, to the 6 milliliter line. I like to put a black mark right on that line so it's a little easier to see. What we want to do is pour without splashing. You can tilt the container a little bit if you want to prevent the splashing. And we want to fill it up to the 6 milliliter line. And the way you do that properly, if you look at my diagram, you can see that as you fill a container like this beaker we have, it will be higher on the edges than it is in the middle. So it'll have a little curve to it. And what you want to do is fill that beaker so that the bottom of that curve, or the lowest point, is at the top of that 6 milliliter line. That's how you know you've properly filled to the 6 milliliter line. And then what we're going to do, once we've filled our beaker to the 6 milliliter level, is place one drop at a time into the beaker and watch the drops as they disappear. If you have a decent amount of hydrogen, quite a few drops will disappear before you have to start even stirring. So have your stir stick ready, but drop your drops in, watch to see that they turn clear, and keep dropping so that you don't stop with every drop and stir, because that actually stirs some of the hydrogen out of the water. So drop your drops, watch them. As you continue to drop drops and count them, you'll notice that the drops will stay blue a little longer. They'll take longer to clear up. So what you want to do as they slow down, then you can stop and stir gently. Make sure it clears up before you continue to add another drop. And then when you finally get to the end of the titration, that last drop will remain blue. It will not turn clear, and that's how you know that you've reached the end of the titration. Make sure though that you count the last drop required to make the beaker turn blue and stay blue. That's important. Once you've got the total number of drops, you want to multiply those drops by 0.1 to calculate your parts per million. So for example, if it took 10 drops to stay blue, multiply 10 by 0.1, and that equates to 1 part per million of H2. This is also equal to 1 milligram per liter. This concludes part 1 of the presentation. We will now go ahead and set up to do the video showing the actual measurement procedure and be back shortly. Welcome back to our tutorial on how to use the H2 blue hydrogen test reagent to test your water for dissolved molecular hydrogen gas. In part 1, we went over the fundamentals of H2 blue and titration, a little bit of the chemistry, and now in this video I want to actually show you how to perform an H2 blue measurement. A note about H2 blue: it can stain surrounding surfaces, so I like to protect an expensive countertop, maybe not wear my best shirt. If you get it on your skin, you'll have to use soap and water to get it off. So just be aware that it will stain if you're not careful. In this experiment, I'm using what's called a magnesium tablet. It contains elemental magnesium, which when reacting with water produces dissolved hydrogen gas. H2 blue will test hydrogen water from any type of device, whether it be an alkaline water ionizer, the new HIMs, hydrogen infusion machines, magnesium sticks, the magnesium tablets here that we're using, and even if you're bubbling hydrogen gas into your water. So you can use H2 blue for any type of hydrogen water that you may have. The type of container I'm using is called a growler bottle. You can find these in beer making stores or online, of course. What's special about this bottle is it has a real good tight seal. The tablets produce a large pressure of gas, and we want to contain that pressure because that will help the hydrogen gas to dissolve into the water. So we want a good seal, and these growler bottles do a great job of that. So what I'm going to do is show you how you just drop this tablet in, and then you want to immediately close the lid as it starts to generate gas. I recommend using one tablet. It produces over 1 ppm of dissolved hydrogen easily. If you go as many as 3 tablets, you could fracture the glass bottle, so be careful there. When you drop the tablet in, you want to immediately press this seal down and lock the lid. And then I like to flip this upside down, and I can see that I have absolutely no air in that bottle. And it's already generating hydrogen gas. In advance of this test, about 25 minutes ago, I dropped the tablet into this bottle. So now it's under pressure and ready to go. And when I open it, you'll hear a pop. And then what we're going to do is we're going to pour 6 milliliters into this graduated beaker that comes with the H2 Blue. I've placed a black mark there so it makes it a little easier to see. Remember, we want to pour the level until the curvature, the bottom of the curvature of the water, or the meniscus, is at the top of that mark. And we don't want to waste a lot of time. We want to move quickly because hydrogen gas is escaping pretty rapidly. You've heard the pop there. If you look closely at the bottle, once you release the pressure, you'll see the hydrogen gas is starting to effervesce just like a champagne bottle. So we want to move rapidly here. I'll pour 6 milliliters in, and I want to get it as close as possible. That's got the meniscus right where I want it. And then we will start dropping drops in. Each drop, remember, represents 0.1 ppm of hydrogen. At first I can drop quite a few drops. 1, 2, 3, 4, 5, 6. You can see that they're disappearing, so I know I'm not even close yet. 7, 8, 9, 10, 11, 12. I'll stop there, and I will gently stir. You don't want to shake this beaker. And at 12 drops, you can see it still turns clear. Let's go 13. Still turning clear. 14. But it's getting close. It's slowing down. I'm going to add one more drop. And as you can see, that 15th drop turns blue and stays blue, so I know I've reached the titration endpoint.